The periodic table, trends. Let's talk about trends in the periodic table. Trends are tendencies of certain elemental characteristics to increase or decrease as one progresses along a row or a column in the periodic table of elements. In other words, a tendency to change in a predictable way. Now let's begin with the atomic radius. Atomic radius is in general stated as being the total distance from an atom's nucleus to the outermost orbital of electron. In simple words, it can be defined as something similar to the radius of a circle, where the center of the circle is the nucleus and the outer edge of the circle is the outermost orbital of electron. The problem when trying to determine atomic radius is where does the electron cloud ends. For solving this problem, scientists have found that it is easier to locate the center of the nucleus, so they measure the distance from nucleus to nucleus of two bonded atoms and divide it by 2. And this is how atomic radius is determined. In here we can see a lithium, francium, neon, and oxygen. Putting two atoms together and knowing where the nucleus are, we can determine the distance from nucleus to nucleus. And this is called the distance between nuclei. And finally, we divide it by 2 and we get the atomic radius. Using this approach, we can see how the atomic size varies in all elements as well as its strengths according to the atomic radius. So the atomic size will increase from right to left in the periodic table and from top to bottom. From top to bottom, it's easy to picture it as we increase the number of electrons, and the more electrons we have, the bigger these atoms will be. Now, it's time for introducing an ion. Atoms that have an overall charge are called ions. In an ion, the number of protons in the nucleus is not exactly balanced by the number of electrons, so there is either an overall positive or an overall negative charge on the atom. Let's check sodium ion. In the left-hand side, we can see sodium atom. In here, we will count 11 protons that are positive and 11 electrons that are negative. So the overall charge of sodium atom will be 0. In the right hand side, sodium has lost 1 electron. So it maintains the number of protons in 11 positive, but the electrons now they're negative 10. So the overall charge will be positive 1, becoming an ion, a positive ion. Now let's check on chloride ion. In the left hand side we have the chlorine atom. Chlorine atom has 17 protons positive and 17 electrons negative, giving us a total charge of 0. Now in the right hand side, as we can see, it has received 1 electron. Now it has the same number of protons, 17 positive, but it has now 18 electrons negative, giving an overall charge of negative 1, becoming an ion. A cation is an atom that has given away at least 1 electron, becoming an ion with a positive charge. A cation is always smaller than a neutral atom of the same element. In our examples, sodium is the cation. An anion is an atom that has received at least 1 electron, becoming an ion with a negative charge. An anion is always much larger than a neutral atom of the same element. In our case, chlorine is actually the anion. Now that we understand what is a cation and an ion, let's define ionization energy. Ionization energy is a measure of the energy needed to pull a particular electron away from the attraction of the nucleus. A high value of ionization energy shows a high attraction between the electron and the nucleus. The trend of ionization energy in the periodic table increases from bottom to top as the electrons are closer to the nucleus, and from left to right as the metal lose very easily their valence electrons. Now let's learn about electronegativity. Electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons to its outermost orbital. The trend of electronegativity in the periodic table increases from bottom to top and from left to right. In other words, fluorine is the most electronegative and cesium is the least electronegative. Thank you for watching.